Hello, welcome to Pluralsight and welcome to this course on Linux systems programming. I'm Dr. Chris Brown. This initial module is called Setting the Scene. Now in this module I'm going to begin by discussing what we mean by systems programming. We'll take a look at the architecture of Linux through a programmer's eyes, drawing a distinction between kernel space and user space. And we'll discuss the use of system calls and the standard library in writing applications. I'll also dive into some of the mechanics of writing an application, the use of header files in C, for example, how to compile your applications, and also how to handle error returns from system calls. Now this is core stuff that we'll use throughout the whole course, so please don't skip this. We're going to be using two languages for the demonstrations in the course, C and Python, and I'll talk a bit about the differences between the languages. And we'll end with a simple demonstration where we'll install the relevant development tools and use them to create our first program, not literally the classic hello world, but something pretty basic. Now, I am assuming that you know some C. You should know the basic language syntax and the data types, and you shouldn't be frightened away by, for example, the notion of a pointer to a structure. As I mentioned, I'm using Python in the course as a more modern alternative to C. If you're not interested in that, you can skip all the Python bits without impacting your understanding of the course. But if you'd like to follow along with the Python examples but don't know the language, let me recommend Pluralsight's Python Fundamentals course. And I'm assuming that you're comfortable with driving Linux from the command line and that you're familiar with standard Linux and Unix concepts like files and links and directories and permissions and processors and pipes. Now, I'm usually reluctant to recommend books because people prefer different styles and have different ideas about what makes a good book. But this one by Michael Kerisk stands so head and shoulders above all the others that I just had to mention it. At 1,500 pages, it's a bit of a tome, but it's authoritative, well written, it's got lots of examples, and it's generally excellent. So, as I'm sure you know, the kernel is the real heart of Linux. It provides services such as memory management, process scheduling, the file system, and the TCP/IP network stack. It implements access controls based on process identity and file permissions. And it also provides the modules, sometimes called device drivers, that manage the actual hardware. All of the software runs in a privileged processor mode. We say it runs in kernel space. All the other programs, the shell, the command line tools, the graphical applications, everything runs in an unprivileged mode. We say that they run in user space. The kernel provides its services to the user space programs through a set of tightly defined entry points known as system calls. At the last count, there were around 350 of these, and they provide services ranging from accessing files to creating processors and network sockets. And it's this system call interface that is the main focus of this course. Now, it turns out that programs don't make system calls directly. They do so via thin wrapper routines in the standard library glibc. Taking the write call as an example, there's a little function called write in the standard library that simply marshals the arguments in the right way and does the little bit of magic necessary to make the jump into kernel space. As another example, consider the familiar printf routine. Now, this isn't a system call, it does all its fancy formatting in user space, but it presumably eventually calls write to actually push the resulting byte stream out. Other library routines, such as squirt, for example, that calculate square roots, operate entirely in user space and return their result to the program without ever diving into the kernel.